Hey Valley Middle, welcome back to another math lesson. Today we're going to begin chapter 6 and take a look at simplifying fractions once again. We'll need that to complete the second video in lesson 6.1. But first let's start off with trivia questions, kind of a picture ID today. Who is this? And it's not somebody from Disney Channel, like my daughter thought. All right, let's move on to the target. Officially today is 6.1a. I can express fractions in simplest form. Let's do this thing. Here we go. What is this fraction in simplest form? Do you remember what to do? Yeah, you just simply divide any number into the top that also fits into the bottom. I chose 5, and so I very quickly simplified this. I divided the top by 5, and I had 3, and I divided the bottom by 5, and I got 5 for a fraction of 3/5. At this point, I just have to ask myself, is there anything else, any number, that will go into both the top and the bottom? And when you can only answer 1, then you know you are now in simplest form. So the only number that these two, the denominator and the numerator, share is 1. So we are in fact in simplest form. Let's take a look at some vocabulary for the day. First of all, simplest form. Simplest form is simply a fraction that cannot be reduced any further. For example, 1/2, 1/3, and 12/13. Here's some fractions that can be reduced further. 8/16, which I can divide by 2 and get down to 4/8, and divide by 2 again and get to 1/2, and there I can't divide them by anything other than 1, so now I'm back in simplest form. These are all equal fractions, but this one is in simplest form. All right, and also 10/15, very similar to the fraction I had on the first slide. We can divide each of them by 5, and we'll get that down to 2/3. But how do you reduce unfamiliar fractions, Miss Jackson? And what have you done for me lately? Let's move on. This is back from chapter 4. A couple of different ways you can simplify fractions. First of all, you can divide them by common factors. And that's what's going on right here. We just chose to divide this 6/24 by 2. So we divide each by 2, and we got it down to 3/12. Well, 3/12 still share a common factor, which is 3, so then we divided 3/12, the numerator and the denominator, each by 3 again, and we got that down to 1/4, which is in simplest form. So you can certainly do that. This is what most people do, and it's what I do. If you know what the greatest common factor is, that's the largest shared number, you can do it in one step. Take a look at this same example, 6/24. By knowing that the greatest common factor of these two numbers is 6, you can do it in one step. 6/24 divide by 6 and you get 1/4. The answer will be the same no matter how you do it. If I know the GCF right off the top of my head, I use it. If not, I usually just jump in with a number that I do know and get those numbers down to a smaller numerator and denominator, which will help me then choose another number to divide by. I also want you to notice that up here, the greatest common factor was 6, and we divided by 3 and by 2. Well, what's 2 times 3? The greatest common factor, which is 6. It's always going to work out like that. All right, let's put it into application for a couple of problems, and then I'll cut you loose to do some on your own. 75 225ths. Well, if I factored them out, you'd see these are the factors for 75, and these are the factors for 225. You'll notice that 75 is the greatest common factor, so by using the greatest common factor method, I can simply divide by 75 and get that down to 1/3 in one simple step. However, the disadvantage is it would take you a while to make a factor tree for 75 and for 225. That's why I usually just go with the second method, which I said just jump in and start dividing. Well, here's what will happen here. Here's another example, 30/45. Now let's say that I did the factors here and I didn't quite do it right. I missed a factor. Like I missed 15 in both of these. I left that out. But let's just say that I tried to make factor trees and I did them wrong. Well, If I still divide by a number like 30 and 45, I divide each by 5, I get that down to 6/9. I can divide that again, each the numerator and the denominator, by 3, and I can get that down to 2/3. Now it's in simplest form, but you'll notice that 5 times 3 will give you 15. That's that missing factor. So greatest common factor, even if you miss a factor, it will still work. The most important thing is to look at your fraction after you've done some division and look and ask yourself, is it now in simplest form? As long as you do that, it doesn't matter which method you use, or if you use a combination of the two methods, it's still going to work out. All right, here's an example for you to try. Why don't you go ahead and pause and express this fraction in simplest form. I see dead people. Okay, I wanted to start off chapter 6 saying that, so I did. All right, let's take a look and see how you did. Well, I divided each of them by 3. I didn't factor them out. I just knew that 3 went into them, and I ended up with 8/11ths. I asked myself, do the numerator and denominator share any factors other than 1? And no, they don't. So 8/11ths is in simplest form. All right, your turn. Again, this one's a little more complicated. Now we've got a mixed number, but still a fraction that needs to be reduced into simplest form. Go ahead and give it a shot. All right, let's take a peek. Well, 14/56 is the fraction that we need to reduce. I knew that 14 went into both, so I divided them both. I'm sorry, I knew that 7 went into both, so I divided 14 by 7, and I divided 56 by 7. I ended up with 2/8, a very familiar fraction that I knew could be reduced further. So I divided both the numerator and the denominator by 2, and I got 1/4. Don't forget, when doing this, you have to bring that whole number over. So my correct answer is 1 1/4. Oftentimes, kids work so hard at reducing the fraction, they forget to add back in the whole number. All right, and one other problem for you to try. Express this fraction in simplest form, 36/16. Now I've given you an improper fraction. Let's see if you know what to do with it. Okay, I'm back. Let's see. Well, we have to start off by taking and dividing 36 by 16. And I just did an old-fashioned algorithm here, and I find out that it goes into 16 goes into 36 2 times, and there's a remainder of 4. So take a look the way I set that up as a mixed number. So here's my holes, 2 holes, and I have 4 left over, and there are a total of 16 in a hole. So there's my 2 and 4/16. I'm going to do that one more time. It goes in there 2 times whole, and I have 4 of 16 remaining. All right, well, I look at it. My work ain't done yet. You know what I'm saying? We have 4/16 here, so we have to reduce that. I knew that both numbers could be divided by 4, so 4 divided by 4 is 1. 16 divided by 4 is 1/4. But don't forget, once again, you have to add in that whole number. So you see me bringing that across for a total of 2 1/4. All right, I think you're ready for the ticket to the show. Here we go. Please express these fractions in simplest form. Bring them to me tomorrow, and we'll be all set for the second part of 6.1, which will be 6.1b. We're going to be looking at ratios. All right, the trivia question. It is not, who are these people? Sorry about that. Let me dump that. Who is this? Well, it's probably the most famous pop star ever's sister. That is Janet Jackson. And she sang a song called What Have You Done For Me Lately? That's where I got that little clue I embedded in the lesson. Here's what she looked like back in the 80s when she was a huge pop diva. She still is. She had a lot of great songs. So, all right, hope you enjoyed the lesson. I'll see you tomorrow at school. Have a good one.